So what's the difference between parallel lines and skew lines? What do you think the difference is between these two? Now, both lines do not intersect. Two parallel lines will never meet up with each other. And the same is true for skew lines. They do not intersect. Now, the difference between the two is that parallel lines are coplanar lines. They exist in the same plane. And skew lines are non-coplanar lines. They exist in different planes. So here's an example of two parallel lines. It takes two parallel lines to determine exactly one plane. So let's say if we have line L and M. L is parallel to M. Now consider these two parallel planes, and let's say they contain two lines. Let's say line J and K. So J and K are skew lines. They exist in different planes, and as a result they cannot intersect because they're not coplanar. Keep in mind, if you have two intersecting lines, they will determine one plane. So two intersecting lines are coplanar lines. Now, because skew lines are non-coplanar, they cannot intersect. If they did, they would be coplanar. So skew lines never intersect. So we talked about parallel lines and skew lines. Now I need to be familiar with perpendicular lines. So let's call this line A and line B. Perpendicular lines meet each other at right angles. They're intersecting lines, and they form 90-degree angles. So we can say that A is perpendicular to B. So let's say if we have a flat plane, and let's call this plane M. And we're going to say this is point A, B, C, and D. So which lines are parallel to each other? We could say that AB is parallel to CD. And we could write it this way. So line AB is parallel to line DC. In addition, we could also say that BC is parallel to AD. And as we can see, BC and AD, they're coplanar lines. They both exist in plane M. And AB and DC, they're also coplanar. They exist in the same plane. Now here we have a right angle. So we could say that line AB is perpendicular to line BC. In this case, these two intersecting lines, AB and BC, they intersect at point B. They both exist in plane M. So we could say that these are coplanar lines. Now we could also say that DC is perpendicular to BC because they form a right angle here as well. Now we can draw a plane like this. And let's say here we have a line, and here we have another line, and then let's say we have another line here. Let's call this AB, and then CD, and EF. Now it's possible that AB can intersect CD at a right angle, but in the plane. And let's call this plane K. So we can say that AB is perpendicular to CD. These are two intersecting lines, and it takes two intersecting lines to determine one plane. Now we could also say that line AB is perpendicular to EF. In this case, the right angle is here. Hopefully you can see that. Now, these two lines, AB and EF, they do not exist in plane K. However, we can draw another plane in which they both exist. They both exist in this plane, which we can call plane S, for example. So any two intersecting lines can form one plane. So even though EF is not in plane K, EF is in plane S, and AB is found in plane K and S. Now another line that you need to be familiar with is a transversal line. So let's say if you have two parallel lines, which we'll call AB, and it's cut by a third line, which we'll call T. T is the transversal because it intersects two parallel lines. And as a result, interesting things happen. So 1 and 2 are alternate interior angles. They exist in the interior of two parallel lines and are congruent. 3 and 4 are also alternate interior angles. 5 and 6 are alternate exterior angles. They're alternate angles because 5 is on the left side of the transversal, 6 is on the right side. And they're in the exterior of the two parallel lines. They exist outside of the two parallel lines. Now 3 and 2 are consecutive interior angles, and they add up to 180. Consecutive interior angles are also known as same side interior angles. Now 7 and 6, well, there's really no relationship that describes them, but 7 and 2 rather, these two, these are corresponding angles and they're congruent. 3 and 6 are also corresponding angles, and 5 and 4 are corresponding angles and they're congruent as well. Now 1 and 7 are vertical angles, they're congruent. 5 and 3 are vertical angles. 4 and 6 are vertical angles, they're congruent. So those are some other things that you may want to know. Now let's say if we have this figure, let's call this A, B, C, D, E, F, G, and H. So what's the relationship between AB and CD? How would you describe them? AB is parallel to CD, as we mentioned before. They exist in the same plane. Now what about BC and HG? Are they parallel? These lines are parallel because you can draw a plane that looks like this. So BC and HG are parallel lines. They exist in the same plane if you draw it that way. Now what about BC and DG? What's the relationship between those two lines? Now those two lines are skew lines. We can't draw a plane that have both of those two lines. So we could say BC is skew to DG because they do not exist in the same plane. And as a result, because they're non-coplanar lines, they will never intersect. Now AB and BC are perpendicular. They do intersect, but at right angles. Now what's the relationship between EF and CD? How would you describe those two? So we can't draw a plane that have both of those two lines. So those are skew lines. These are non-coplanar lines that will never intersect. So CD and EF are skew lines. So if we look at CD and if we extend it, CD and EF will never intersect. Now EF is going this way and CD is going this way. Now, it appears that they intersect here, but in reality, if you actually draw these two lines, they do not intersect. And the same is true for BC and DG. These lines should never intersect. So those are skew lines. Perpendicular lines do intersect. So AB and BC, they do intersect at this point, and they meet at right angles. Now, what's the relationship between, let's say, BE and DG? Notice that those two lines are parallel because we can draw a plane that contains those two lines. So that plane, which is basically the diagonal of this rectangle that we have, it shows that BE is parallel to DG. So hopefully this box or this rectangle gave you a good illustration of how to tell if two lines are parallel, if they're perpendicular, or if they're skew lines. So that's it for this video. Thanks for watching and have a good day.